something that is huge, okay? The first thing that when we talk about simplifying expressions is something called like terms. So that's what we're going to focus on today. Are things, what are like terms? What do like terms look like? How do I put them together? Things like that, okay? All right, so an expression, when you're hearing me say expression, an expression is not equal to anything, okay? An expression is just there. There's no equal sign. But an expression will always have a variable or a number. And a lot of times they'll call a number a constant and operations. So like adding, multiplying, dividing, subtracting, okay? Can anybody tell me why a number might be called a constant? Aiden?
Because numbers never stop, they just keep going down or going up.
Mm-hmm. No, Timmy?
It's not added or subtracted, anything look the same.
It's the same because it does not have a variable. That's why it's a constant. So a variable is something that could change depending upon what the value of that variable is. Okay, so like x is a variable, m is a variable, p is a variable. A constant is a number that does not have a variable on it, which means it cannot change because there's no variable. So this expression right here, we're going to label it, okay? So this expression, this right here, this negative 6x is called a term. This negative 6x plus 12 is made up of two terms, okay? So this is actually one term, two terms. But they don't call that 12 a term because it doesn't have a variable on it. So this is a constant, the number, because it does not have a variable on it. The sign between, so if it's adding, multiplying, dividing, subtracting, that sign is the operation. So you should be labeling these on your paper just like me. You're writing these in place? What's this x called? The variable. And then this is a new word for us, coefficient. A coefficient is just the number that's in front of a variable. So I'll be like, hey, what's the coefficient of 3x? You would tell me 3. What's the coefficient of 25p? You would tell me 25. It's just the number that's in front of that variable. That's the coefficient. C-O-E-F-F-I-C-I-E-N-T. Okay. So terms. Terms can be classified as either like terms or unlike terms. And can be simplified by combining like terms, which they put combing like terms. They can't spell the word combining right. Let's combine it.
hard to talk with special events.
As I said, if anybody makes fun of me for having like a beard of pimples after this mask thing,
It's all right.
they're gone.
We're gonna make them.
Alright, here's the most important part, okay? Like terms must have the same variable and exponent. Okay, that is the biggest deal. In order for them to be like terms, they must have the exact same variable with the exact same exponent. Star it, highlight it, something. That's the biggest deal on everything we've done so far. So just because they have the same variable does not always make them be like terms. They also have to have the same exponent on them. Or just because they have the same exponent doesn't make them like terms unless they have the exact same variable. And we're going to talk about things that are like terms and unlike terms. All right, just a second to get caught up. Yep,
Do we have to wear a mask all of the year?
just for the rest of this month, and then they'll reevaluate at the end of the month.
Oh, okay. Yeah.
We're good. All right, I'm gonna kind of skip around here. I hate when I do that. Okay. So it says, in this table at the left, determine which of the terms are like terms, and the table at the right, determine if the terms are like or unlike. So I'm gonna start on this right side. And I'm gonna determine if things are like terms or unlike terms, and that's all you have to write in that box. Now, like terms are either both plain constant numbers, so like 3 and 5 are like terms, and things that have variables on them, they have to be the same variable with the same exponent to be like terms. So a lot of people would think, okay, 29 and 29 squared, those are not like terms, is what people think. But 29 squared is a number. 29 squared is 841. So are numbers like terms? Yes, numbers are always like terms. So those are like. And they're like terms because they're both numbers. Neither of them have variables on them. Okay, B and 3B. Now I have a question, see if I remember this from last year. If there is no number in front of a variable, what's automatically assumed to be there, right? 1. So this is like a 1B and a 3B. Are those like terms? Do they have the exact same variable, the exact same exponent? Yes. Now, when you're looking at it, you're like, Ms. Wilson, but one of them's a 1 and one of them's a 3. The coefficients have nothing to do with whether they are like terms or not. That's why we wrote that like terms have to have the same variables with the same exponents, okay? So these both have the same variable of B, and they both have the same exponent of 1. So these are like terms. All right, what about the numbers 6 and 9? Are they like terms? Yeah, because they're both numbers. Numbers are always like terms because they don't have any variables on them. These are also like. All right, McBride, is negative 3R and negative 3P like terms?
No.
No, those are not like terms because one of them is an R and one of them is a P. In order for you to have like terms, they have to be the same variable with the same exponent. So these are not like, so I'm going to put unlike. All right, 13K and 13K squared. Remember, we wrote down and started, like terms have to have the same variable, which they do, with the same exponent. Do they have the same exponent on them? So this has a power of 2 and this has a power of 2. No, those are not like terms. Yes, they are both k's. Yes, they are the same variable, but they are not the same exponent. One is k to the first power and one is k to the second power. They have to be exactly the same variable with exactly the same exponent. So this is why it's unlike. All right, c and c to the fourth. What do you all think about that one? Unlike. Yes, they are both c's. So yes, they are the same variable. But like terms have to be the same variable with the same exponent. One of them has an exponent of 1. This one has an exponent of 4. So that's why they're not like, because they're not the same exponent. Okay, this one, 1c, because that's like a 1, 1c, 4c, 8c. Are those like terms?
Yes.
Yes. They are all both, or all three of them are just c. That's c to the first, c to the first, c to the first. They're the exact same variable with the exact same exponent. So yes, those are like terms. All right, what about the last three numbers? Are those like or unlike? Why?
No,
It's like.
They're all numbers.
Yeah,
it's like terms. All numbers are like terms. All numbers are like terms because there's no variable. If there's no variable, then they're like terms. Okay, we're gonna do more, so it's okay. All right. So this box on the left says determine which of the terms are like terms. Okay? I'm not going to make you write them all out. We're going to circle them, okay? All right, so here's my question in this first row. 8c, 16, negative 8c, negative 16b. Are there any like terms in that row? Are there any that have the same variable with the same exponent?
Yeah.
Which ones?
8C and, 8C and 8C.
These two are like terms, just those two. And the reason those two are like terms is because they are the exact same variable c with the exact same exponent. All right, look at this next one. And I'm just circling them. You can write them in the side, but we'll just circle them over. 12, negative 12x, and 12x. Do you have any like terms in there? The x's, the 12x and the negative 12x are like terms. These are like terms because they are both x and x with no exponent on them. So they're the exact same variable with the exact same exponent. This is not a like term. Just those two that I circled. All right, looking at this one, 9y, 5z, and 9w. Do you have any like terms? No. Because one of them is a y, one of them's a z, one of them's a w. None of them are like. So this one I would just put none. Because there are no like terms there. All right, what about this row? 11g, 11, and negative 7g. The 11 and the 7. 11 and negative 7. So 11g and negative 7g are like terms because they're both g's. They both have the exact same variable, the exact same exponent. All right, I'm going to wait a second and I want you to finish these four. Okay, I want you to circle what you think might be like terms.
Yeah. Is it an emergency? There'll be extra speedy on those arms. You can't be speedy. Go, pump those arms. Like you lost your kid a couple stores down. Come on, that's not arm pumping. That's when you lost your kid. One time I lost my kid in the store. For like 30 seconds, but I was in panic mode.
All right, so this one, are there any like terms in this row?
Yeah.
What? The T's. These T's are like terms because they're both T's, the exact same variable, the exact same exponent. All right, what about this row? Are there any like terms?
Yeah.
The N's and the M's. The M is in man. One M and M. They're both the same variable, the same exponent. All right, what about that next one?
Yes.
The B's, all the B's. So 4B, 1B, and 9B. Those three are like terms because they're all just B's. The same variable, the same exponent. The number out front has nothing to do with it. All right, what about that last one? What?
0 and negative.
The numbers are like terms. The numbers are like terms. Numbers are always like terms because they don't have a variable on them. Okay? Are there any questions that you all want to talk about before we start putting them together? No. All right, here's my question. What's 3 apples plus 5 apples?
8
8 apples. What's 3A plus 5A? 8A. You just did it. That's combining like terms. 3 ducks plus 2 ducks. Okay. 3D plus 2D. 5D. Wow, you just combined like terms. See that? Okay. All right. So on the back, we're going to talk about some like terms. So only like terms. So like terms are the only things that can be combined. So you cannot put apples and ducks together, which means you cannot put A and D together. Okay, they have to be like terms in order to put them together. All right, so they're kind of showing you what I was saying out loud. I used apples and ducks. They're using pizzas, ice creams, and sodas. Okay, so it says the Robinson family ordered snacks at the state fair. They bought the following drinks: D, pizza, P, and ice cream cones, C. So it says write an expression to represent their purchases. So what that means is I'm just going to label them. So they bought pizza first, right? And then they bought another piece of pizza. And then they bought a what? Pizza, drink. So I did pizza, a drink, plus another drink, plus an ice cream cone, plus pizza, plus ice cream cone, plus pizza, plus a drink. Okay? Now, those are all the things that they bought. But you could make this more simple. You could write it as something that has the terms combined. So here's my question. How many pieces of pizza did they buy? 5. They bought 1, 2, 3, 4, 5. So they bought 5 pieces of pizza, right? Ready? 1p plus 1p plus 1p plus 1p plus 1p is 5p. All right, how many drinks did they buy from the picture? 3. So they bought 3 drinks. 1D plus 1D plus 1D is 3D. And then how many ice cream cones? 2. So 2 ice cream cones. Look at the sentence that we wrote out. 1C plus 1C is 2C. So you can put together things that are the same, things that have the exact same variable with the exact same exponent. Okay? So that's what we're going to do at the bottom here. We're going to combine like terms. Now, what if you're looking at something and they don't have like terms? Then you would just rewrite it the same way. Okay? Or if you just have one random term that does not have a like term, you'll just tack it on to the end. Okay? No, we're going to actually put them together. All right, so we're going to do number 1. We're going to do a few of these together. Okay, so on number 1, 7a minus 6 plus 8a. So before you do it, here's the question you should ask yourself. Do you have any like terms in number 1?
Yes.
What?
7A and 8A.
7a and 8a. So these are like terms. Now, I'm going to tell you all, again, even though I've said this about 150,000 times in the past few weeks, the sign in front is the sign that it keeps. Sign in front is the sign that it keeps. So when I look here, what kind of 7a is that? Positive 7a. What kind of 8a is that? Positive 8a. So 7a plus 8a is 15a. And then that minus 6, it doesn't have any like terms to go with, does it? So I'm just going to tack it on to the end. And since it's the minus 6, I leave the sign in front. The sign in front is the sign that it keeps. And that's the answer. So we're not solving anything. There's nothing to solve because these are expressions. And expressions are not equal to anything. Expressions are just another way to write something. And let's do number 2 together. All right, so number 2, 14b plus 6b minus 12. Do we have any like terms?
Yes.
I do. The 14b and what else? The 6b. Those are like terms because they're both just b's. So I'm going to put them together, and the sign in front is the sign that I use. So this is a positive 14. This is a positive 6. So 14b plus 6b is 20b. And then I have that minus 12, which does not have any like terms, so I just tack it on to the end. Wake up, wake up. All right, let's look at number 3. This one's got 4 terms in it. Ooh, doggy. All right, so looking at number 3, 20c plus 8d plus 20c minus 5d. Okay, can somebody raise their hand and tell me one set of like terms? Ethan? Okay, Sakshi? Yes, so I've got 2 sets of like terms in this problem. So I'm going to combine each set of like terms. So we'll start off with the c's. Remember, the sign in front is the sign that keeps. So that's a positive 20 and that's a positive 10. So 20c plus 10c is 30c, because 20 plus 10 is 30, right? Okay, and then now I'm going to look at the d's. What kind of 8 is that? Positive. What kind of 5 is that? Negative. Negative. So 8d minus 5d is a positive 3d. Since the answer, when I combine the 8d and the minus 3d, or 5d, sorry, was positive 3b, that's why I put a plus sign. If it was a negative number, I would put a minus. But since it's a positive number, 8 minus 5 is 3, I put plus. Yes, Jackie? Yeah, because when you took 8 minus 5, what is 8 minus 5? What kind of 3? That's why I put plus. If it was a negative, I'd put a minus. All right, you all try number 4 yourself. All right, so on number 4, do I have any like terms? Yes, what? All of them. They're all like terms. Now, when I add and subtract, order of operations say I add and subtract from left to right. So these are all like terms because they're all D. So here's my question. What's negative 3 plus 8? 5. And what's 5D minus 5D? 0D, which is 0. So that one just equals 0. Because 0D is 0 times D, which anything times 0 is 0. So, all right, try number 5. Okay. All right, so on number 5, do you have any like terms?
Yes.
What?
3E and 7E.
3E and the negative 70. Okay? So, do I have any other like terms? The negative 19 and the 10, because those are both numbers. And numbers are always like terms. So I'm going to put together just the E's. What kind of 3 is that? Positive. What kind of 7 is that? It's negative. Because the sign in front is the sign that it keeps. So 3 minus 7. Negative 4. Negative 4E. Okay, so I put together just the E's. 3E minus 7E is negative 4E. Now I'm going to put together the numbers. What kind of 19 is that? What kind of 10? Positive. So negative 19 plus 10 is negative 9. What? What were different? No, because they're both numbers. So numbers, constants are always like terms because they don't have any variables on them. All right, try number 6, and then we'll stop there. I will tell you this. If there's no number in front of a variable, we put a 1 there. So that's a minus 1f. And I'm totally okay with you all using a calculator to back yourself up and check it on this, okay? So if you're not sure that negative 19 plus 10 is negative 9, use the calculator to back yourself up. But I will tell you, every once in a while, I'm going to have random pop quizzes over integers. Because that's one skill we've got to pick up. Also, sorry to tell you all this, but this was the lowest class on my test Friday.
Not Friday.
Yeah,
Friday. I got a 94.
That test from Friday, this class was about 10% lower than the other two. Yeah. I'm planning on doing. It's in Infinite Campus. I plan on doing some remediation during flex times, so hopefully some of you all might be able to retake it.
I have a question.
Yeah.
What about the one on like Wednesday or Thursday? The one out of 16?
Oh yeah.
Were we the lowest on that one too?
All right. All right. Number 6. Like terms are these F's and these numbers. So this is a negative 4F minus 1F. So negative 4 minus 1 is negative 5F. And then this is negative 9 plus 15, which is positive 6. I really want you all to try your best on this homework. I don't want you to rush through it. I literally just had that in my hand. We're gonna mark some of them out for right now. We'll come back to them on Thursday. Yeah. If it's got a plus sign or nothing in front of it, then it's positive. If it's got a minus sign or a negative in front of it, it's negative. All right, guys, listen up. All right, on that homework. On the homework, we are going to mark off 12, 13, and 14. So we're not going to do 12, 13, or 14 right now. We might come back to it later, but right now we're not going to do those 3. I want to go over the top part with you real quick. So cross off 12, 13, 14. Everybody good with crossing those off? Because I'm real good. All right, on the top, it says list 3 terms that are like the given terms below. So they want you to make up, everybody listening? You're going to make up your own like terms. So like if I do number 3, 42BC, like terms just have to have the exact same variable with the exact same exponent. So these are BC, so how about 4BC, 7BC, and 2BC. So I'm just writing my own like terms that have the exact same variable as the problem. Okay, can somebody tell me some like terms for 2R? Just tell me. 10R. 10,000R. 8R. 13R. Okay, so just some like terms for those. Okay. All right, so we've got about, we get early lunch, so we have about 7 minutes. You could probably at least finish that little top section.
While we're working, can you also show us the video?
Yeah.
Oh, when it says negative y, can we just put like negative 3?